So let's start off by just looking back on what a quadratic equation is. So a quadratic equation is always in the form ax squared plus bx plus c. So there's an x squared term, an x term, and then a constant term. Sometimes one of those elements are missing, but the one thing that cannot be missing is that there's an x squared or a variable that is squared. Immediately when there is a variable squared, that makes it a quadratic equation. Equation, also important, it must have the equal to something on the other side. Otherwise, it's not an equation. So, and you might recognize this for when we solve quadratic equations, especially those ones that we couldn't factorize, we used this formula. Do we recognize this formula? Put a thumbs up in the chat if you recognize the formula that you used for solving quadratic equations if they couldn't factorize. The ones that factorize, you can use this equation, this formula for as well, but especially for those that couldn't factorize. Okay, some are recognizing that formula. Good stuff. So when we talk about the roots of a quadratic equation, we are actually talking about the x values when the equation is equal to 0. So roots is just another term or another word for the actual x values, the solutions to the equation. And at the same time, those roots are also the x-intercepts of the graph. So, Ms. Lebo, have they done quadratic graphs? Have they drawn parabola this year?
No, we haven't done functions yet.
Okay, but from last year, you did draw some quadratic graphs, and you did draw the parabola, and this year you're going to do that again. But the graph, if you think of the graph of a quadratic function, and it just to remind you, it looks like that. So these points where the graph goes through the x-axis, those are actually referred to as the roots. Okay, so if you were wondering what the roots are, they're just the x values. And now we get to this whole thing of determining the nature of the roots. And when you are talking about the nature of something, the nature, like what is my nature? Or what is the nature of a certain object or anything that you're describing, then we are saying basically, what is it like? We are describing what it is like. Okay, so it normally goes with some sort of a description. So if I would have to describe the nature of my best friend, for instance, I would say she's really friendly and she's very caring and she is a really good person. So that's somebody's nature. So we are going to basically describe the nature of the roots. So the nature of the x values. We're going to describe what they are like when we do the nature of the roots. So when we do the nature of the roots, we do not solve the equation. Okay, so that's something that you have to get your head around, is that when we are just talking about nature of the roots, we're not solving the equation. The quadratic equation, we are just describing what those roots are going to be like, what their nature is. Alrighty, so let's go back a few years to grade 8 or grade 9, and let's look at our number system. And if you remember the number system, we had all the rational numbers. First of all, if we start off with the real numbers, the real numbers are all those numbers that exist. That's what makes them real. And you get two big groups, irrational and rational numbers. And within the rational group, we have integers, whole numbers, and natural numbers. Then on the outside here, on their own, and I think we can even say, let's make this block here one color, and that's our real number system. And then on the outside here, we have the non-real numbers. The non-real numbers are generally stuff like square roots of negative numbers, division by 0, and irrational numbers are numbers like pi. So they have decimal fractions that carry on into infinity. Like for instance, pi, they still haven't found the last digit of the number of pi. So that makes it irrational. The square root of 2 is irrational. The square root of 5 is irrational, etc. And rational numbers, those are basically everything that's a fraction. Everything that we can say, I take one number and I divide it by another number, and that can be positive or negative. So all the fractions, integers, we know what those are, positive and negative numbers. Whole numbers, that includes 0, and the natural numbers are just all the positive numbers, 1, 2, 3. And we work with those more when we are doing junior maths, but when we get to senior maths, we focus on the integers and the rationals and the irrationals. But that's basically what our number system looks like. And roots can be any one of these numbers. So when we look at the roots of an equation, it can fall into any one of these groups. It can be non-real, it can be irrational, or it can be rational. All right, so let's see how we are going to do this. Let's just first sort of refresh our memories. Which of the following numbers is irrational? And it's fine if you want to use your calculator for this one. So let's punch into the calculator root of 16. What do we get? Put that in the chat if you have an answer. Yeah, that's 4. You could have done that without a calculator. And what is the square root of 1,6? Put that in the chat. Let's see what you get. Okay, so I see some people are rounding, but if you do put that into the calculator, you do get 1,64911, and then some decimals. And what about the square root of 1,600? What do we get there? That's 40, correct. And the square root of 0,16. What do we get? 0,4, or 2/5. Okay. I see Nati's hand is up. Nati, you can unmute and ask your question. Nati, you can unmute. Nati's gone. Okay, so which one of these is irrational? Put your answer in the chat. Irrational, remember we said if we have a number that's got decimal places that do not terminate. That's basically what it comes down to. It carries on into infinity. So that's lovely. Yes, B is our answer for that. So the others are all rational numbers, and they are also, I'd say the first one's an integer, and C is also an integer, and then D is a rational number. Excellent. Right, guys. So that's just a bit of, because we're going to use that when we actually describe the nature of the roots. We're going to use those words to describe the nature of the roots. All right, so maybe this is something you want to take a screenshot of, or definitely write down, or if you have a textbook somewhere, if you have it already, if you've done it in school already, maybe. This is important. This you need to know in grade 11 off by heart. Okay, so big bubble around that, or big cloud, important stuff. To find the nature of the roots of a quadratic equation, look at the value of D, the discriminant. Okay, so what on earth is the discriminant? So let's sidestep here for a second. And the discriminant is, we use this symbol for it. And if we go back to our formula here that we use for finding the roots of an equation, for solving especially those ones that cannot factorize, the discriminant is just this part here under the square root, b squared minus 4ac. That is the discriminant. And you'll often hear it referred to as delta or the discriminant, or yeah, I think those are the names that are used for it, but it is b squared minus 4ac. And it's the part that goes under the square root in the quadratic formula. So it comes directly from the quadratic formula. So you see how everything's interrelated. Now, if that discriminant is smaller than 0, in other words, it is negative, then the roots of the equation that you are looking at. So remember, we're not solving the equation, we're just describing what the nature of those roots are. Then the roots are non-real, or there are no real roots. So think about it. If you have that discriminant and it is the bit that's underneath the square root in your quadratic formula. So say it comes out as a number smaller than 0. So say it comes out as like -4. What do we know about the square root of negative numbers? That doesn't exist. That is non-real. So that's basically what it means, that you get your delta, you work out your delta, and I'm going to show you how to do that now. And you get a negative number, and that means your roots are non-real, meaning no solutions for x. Okay, now delta, if you work it out, it can be equal to 0, and that means there are two equal real and rational roots. So they're equal, they're real, and they're rational. The other situation that can happen is that delta is greater than 0. Then it means there are two real roots that could be rational or irrational. So two real, two equal, non-real. That's our scenario so far. And if delta is a perfect square, the roots are rational. So we've got delta smaller than 0, delta equal to 0, delta greater than 0, and delta is a perfect square, and then the roots are rational. Okay, so that's a mouthful, and just hang on and follow along as we go, because we're going to use this now. So screenshot this or write that down quickly, and we're going to refer back to that as we get to our actual questions. Okay, right, so let's see. Determine the nature of the roots of the following. So here's our first example. So when they say nature of the roots, we are not going to solve the equation. We are just going to determine, we're going to see what delta is equal to. And then we're going to describe the nature of the roots according to these four sort of classifications or categories. So the first one, x squared plus 1x minus 1. So remember, we do ax squared plus bx plus c is equal to 0. So what you might want to do is write down what a is. In this case, it's 1. Write down what b is, and that's 1 as well. And write down what c is, and that's -1. And we're going to put it into our delta or our discriminant. And that's going to be 1 squared minus 4. And c is minus 1. And we get 1 minus 4 times 1 times minus 1 is going to give me plus 4. And that is 5. So delta is 5. So that does not mean that the roots of the equation is 5 or anything like that. It just means that that part under the square root is 5. And if it is 5, now we can look. Delta, is it smaller than 0? No. Is it equal to 0? No. But it is greater than 0. So that's the first thing you write down. So you say therefore, delta is greater than 0, comma, and now you're going to say what the nature of the roots are. The roots, there are 2 real roots that are rational or irrational. So it's fine for you to just write roots are real. Okay. So if delta is greater than 0, then the roots are real and they could be rational or irrational. Okay. There's a question, isn't delta the square root of 5? No, we don't have a square root anywhere here. We just calculate, we substitute our a, b, c into our formula, b squared minus 4ac, calculate what that is, and we get delta is 5. So yes, it goes under the square root, but the actual value that goes under the square root in the formula is 5. So the value of delta is 5. It's not square root 5. It's what goes under the... No problem. Okay. Right. Let's go to any other questions. Put them in the chat or raise your hand. Any other questions? Then we're going to go on and you're going to try this one next. Okay, so I want you to determine the nature of the roots of this one. Okay, so I'm going to pause here for 2 minutes and let you calculate what delta is. And if you want to do the next step as well, say what the actual nature of the roots is. No, don't add the square root to the answer, okay? It's just for you to understand that the discriminant b squared minus 4ac is the part that goes under the square root in the quadratic formula. We are just working out b squared minus 4ac without the square root. So we're just taking, for your question about the difference between this and the quadratic formula, we are just taking that part of the formula that's under the square root, the b squared minus 4ac. So there's no difference. We're just working with a certain part of the formula. Let's see some answers. Some of you are quick. Let's get some more answers up, guys. Even if you maybe get the same, post your answer anyway. It's a good way to stay engaged and participating in the lesson. Okay, let's see. And those of you who have given an answer, now I want you to check what is the actual nature of the roots. If delta is 49 and you're sure about your answer, then also put what the nature of the roots are. Remember, there are 4 possibilities. In this case, which is it? Is delta smaller than 0? Is delta equal to 0? Is delta greater than 0? Or is delta a perfect square? Okay, so our B value is 3, so we substitute that in. Our A value is 2, and C is -5. So that is 9. You don't have to do this in your head. You can use your calculator. That is plus 40. So delta is 49. Okay, so everyone's saying, yes, delta is greater than 0, but 49, guys, is a perfect square. A perfect square being 7 times 7 is going to give you 49. So delta is a perfect square, so the roots are rational. So therefore, delta is a perfect square. Roots are rational. Okay, so watch out for those perfect squares, like 25, 36, 49, etc. That will make the roots rational. Okay, good stuff. Next one. Let's do this. Work out what is delta and then also say what the nature of the roots is. Put your answer in the chat as soon as you have one. Yes, so while people are working and thinking, you can also ask a question. Let us know if there's something you are wondering about. If you have delta, then also work out, also say what the nature of the roots is. Okay, let's sub this in. Let's see what we get. So b squared is -1 squared, -4. A is 1. C is -30. 1 plus 4 times 30 is 120. And indeed, 121 is also a perfect square. Good stuff. A few of you spotted that. So delta is a perfect square. Perfect square. And the roots are rational.
Well done, guys.
Good stuff. Okay. Let's do the next one. Now, don't be caught out by this one. Write down your A, your B, and your C. Okay, so A is 3. There's no middle term. There's no bx. So that's going to be 0. And then C is 5. So then now b squared is 0 squared. And then A is 3. And C is 5. I think some of you might have mistaken the 5 for the b. But if we look at our standard form, ax squared plus bx plus c, this is not here in our equation in question D, but c is. So c is 5. So what we get is minus 4 times 3 times 5, so it's minus 60. So delta is smaller than 0. Therefore, the roots are non-real. Yeah, so like I said at the start, be careful. Don't get caught out by the 5. It's not B. Make sure you use the right values. Okay, let's do one more and then we'll do our brain break. Question E. Remember to ask any questions if you want, or to put them in the chat. Who's got an answer for this one so far? Huge answers people are getting. It's possible because the B value is negative 43 and we're going to square that. Okay, so let's put that into our calculator. Yes, I also get 1,369. So delta is 1,369, a perfect square. Let's see, 1,369. Oh, wow, it is a perfect square. It's greater than 0 and it's a perfect square. Always check, eh? Especially if the numbers are this big. Therefore, the roots are rational. Good, excellent. Alrighty, let's go to our brain break, guys. You're doing so well and getting a hang of the nature of the roots quite quickly, quite well. So there we go. So there's our numbers. And I believe these need to make 24. You need to put them together somehow and make 24. Let's see who can come up with an answer. Put your hand up if you've got it. Oh, Tula seems to have it. Oh no, hand down again. 2 times 8 plus 7. Nice. Yeah, that will work. 16 plus 8. Okay, so apparently the blue is a bit easier. So I think we are ready to go to the red. Let's do that one. Seven minus 1. Yo, you guys are quick. Sakile got it very quickly. 7 minus 1 is 6. And then you multiply. Oh no, it's doing the other one.
It's funny because the blue is usually the harder one and they got it so quickly.
Oh, is the blue the harder one? I thought the red is the harder one. Okay, so next one. Oh, Bomaglaka got this one. 7 minus 1 is 6 times 2 times 2. Yeah, got it.
Nicely done, guys.
Nicely done, yeah. Nothing wrong with your mental maths. Okay, back to our, if you want to have a stretch, you can, but apparently Mr. Skitter makes you do some exercises. If you want to, you can. I'm going to just stay in my chair because I'm not going to stretch today, but you're welcome to do that quickly if you want to. Alrighty, back to nature of the roots. And let's do this one. I think this can be our last one, and then we can move on to some of the other questions that he had prepared here for you. So let's do this one and maybe one more. Right. X squared minus 2x plus 1. Give us the nature of the roots. And then tell us what the nature of the roots is. So what is delta equal to, and how would we describe those roots? Yeah, guys, so if you're putting your answer down for delta, you must also now say, what does that mean for the nature? Describe the nature of the roots. So A is 1, B is -2, C is 1. Yeah. Okay, so it's not enough just to say that it's 0 or anything. You have to give the description. What is the nature of the roots? So for a question like this, by the way, as well, it's normally about a 3 or 4 mark question. And we'll show you now where the marks go. So delta is 4 minus 4. Delta is 0. So you'll get a mark for substituting incorrectly, and then for working it out, and then for describing and saying that the roots are equal. Okay, so it's an easy little 3 mark question on the test or exam, and it will come up. It's bound to come up, either here or when you do the graphs that go with the quadratics. Okay, one more. Let's see. Let's do this one. X squared minus 4. So A is 1, B is 0, C is minus 4. So B is going to be nothing. A and C is minus 4. And we get delta is 16. So delta is a perfect square. We've had a lot of these today that were perfect squares. So the roots are rational. Seeing some beautiful answers in the chat. Or actually, yes, let's put that real and rational. Nice. Okay. Hope you didn't get caught out again by the missing B. Okay. Right, so let's look at the next one. The roots of the equation x squared plus 3x is equal to 4 are, and then there are options here. What do you think we need to do before we start our work here? What does this need to look like first? What do we need to do? Put it in the chat. We've got x squared plus 3x equal to 4. Transpose the 4. Wow, that's a big word, Ayanda. Can someone else? Annie says standard form. Move the 4 to the other side. That's right. So before we can do delta, we need to move that 4 to the other side. Yes, make it standard form. Lovely, guys. 3x minus 4 is equal to 0. We'll do that. And now we can do delta. We can say delta is b squared minus 4ac, and off you guys go. Work that out for me, and then tell me which answer is the right one, A, B, C, or D. Eunice says already that it's C. Let's see if the rest of the class agrees with her. Kuma says no, it's B. Okay. What is the value of delta? The value of delta, we're going to work out, we're going to sub in b is 1 squared, a is 3, c is minus 4. So then delta is 1 plus 16 times 3, 16 times 3 gives me 48. Am I working it out right? I'm getting delta 49. Did I do something wrong? Oh, yes, I plugged in my b as the wrong value. Thanks, guys. So that is 3. That is going to be 1. And then delta is 9 plus 16. I still get 25. 9 plus 16 is 25. So I still get that delta is a perfect square. So the roots are real and rational. So real and rational, let's see, perfect square. Just says that it's real and rational, okay. For equal roots, delta must be equal to 0. So I'm going to go with C as well and say that it's real, rational, and unequal. Because delta is a perfect square. Well done, everybody. Just understand why it's not B, because for equal roots, delta must be equal to 0, and our delta is equal to 25. So I think C here is the best option. Okay, I think we can do the next one as well. Same story, work out what it is, and then tell me if it's A, B, C, or D. Put it in the chat. Straight away, people are saying it's A, non-real. Let's see what B is. B is minus 4 squared. Minus 4 times 1 times C is 13. So that is 16 minus 13. So delta is 3. Did I put something in the wrong place again, Miss Lebo? Because I don't get delta as non-real. I don't get the roots are non-real. Oh, I missed my 4. There we go.
Oh.
So 16 minus 4 times 3. Minus 4 times 13 is minus 36. Minus 36, and you guys were right. It's non-real.